All right, hi everybody. This is the Math 31 derivatives review. This is question 15b. What I got to do here is sketch the first and second derivative of this function here. Okay, now notice that this is a quartic. Okay, or at least roughly, that's a good guess here. It's a quartic, a fourth degree. So my anticipation here is that my derivative is going to look like a cubic. Now let's just take a look here. I know that the derivative is going to have a value of 0 here. So put a mark right there on the x-axis as 0. It's going to have a value of 0 here. And it's going to have a value of 0 here. Now that point is already right there, so that's kind of nice. It's convenient. And the reason for that is because the tangent line is going to be horizontal here. It's going to be horizontal here, horizontal here. Now let's just talk really briefly about what's going on here. The tangent line to all of these points all the way down to here are all going to have negative slopes. They're all going to be pointing down, except that they're going to be increasing, okay? Because the line is, as I draw the line along here, the tangent line, to get around this curve, it's got to kind of rotate. The values are getting like large negative numbers, smaller and smaller negative numbers until you get to 0. So this part of the curve is going to actually be below. The derivative is going to be below the x-axis to represent those negative values. From here to here, the slope of the tangent lines are positive. Okay, they increase. The line starts to twist to point up until it hits a maximum value, and then it starts to decrease again to this point right here. So what's going on here is this thing is, the derivative is going to come down from below, it's going to come up, and then somewhere around here, okay, it's going to hit a maximum. And I don't know what that maximum value is. At this point, that's not our purpose here, is finding that number. The purpose here is just to see the trend here. So it's going to hit a maximum value, then it's going to drop back down to here. In between these 2 points, okay, the tangent line hits a 0 here. The tangent line, the slope drops as the line rotates down. It's going to hit a minimum value here, a minimum like negative value. Because then the line starts to rotate again this way until it gets back to 0. So this thing's going to drop down, and I'm not entirely sure how far down it's going to go, but it's going to go down, hit some sort of minimum value, and then turn back up to go through 0. And then from this point in time, as you go along the curve here, all your slopes are going to be positive as the line rotates up, and so our derivative is going to just increase. And that's what our first derivative is going to look like, this nice little cubic here. Now we take the derivative of the cubic. Okay, so the slope of the cubic, the slope of the tangent line is going to be 0 here, 0 here. So that's going to be this point right there. This point right there. Notice that to this side right here, all of the tangent lines are going to have positive slope. Large positive slope, getting smaller and smaller and smaller to 0 until here. Then all of a sudden I've got negative slopes in along this part of the curve, okay, as the line goes down. So the tangent line hits here, rotates down here, hits a minimum slope, and then it curves back up to 0. So that means the derivative is doing this. It's coming down. Whoops, shoot, wrong line. Sorry, I was going to the wrong point there. It's this point that I want to go to. So the slope comes down to here, hits the 0 line, the 0 point, drops down to some sort of minimum value, curves back up through that point right there where it goes to 0. That corresponds to this spot right here. Okay, so remember the point where the derivative goes through 0 is directly below those maximums and minimums. And then the cubic, the derivative here is positive all the way up. So it goes like this. And there, right there, is our quadratic, which is what I would expect. I would expect the derivative of the cubic to be a quadratic.